two of the authors are here, me and Rohan, and we'll be walking through the research paper that we have published. Like the title is Comparison of Sequence Model for a Text Narration from Tabular Data. So this is a like a survey paper where we are suggesting the approach that we will be following and what we have done the research and how we'll be taking this research forward. So I'll just give a brief overview of the things that we have doing. So like understanding the text from the tables requires a lot of human effort, and it takes a lot of time. So we suggest a NLP approach where if we try to fit a tabular data to a particular NLP model, it will try to generate the meaningful text from that particular table. So like this research paper focuses on the transformer based model, and the goal is to generate human readable language text from the input. So it should be a meaningful sentence that can be read by a human instead of going through the tables. So this is the overview in which we'll be talking. So I'll just move to the next slide. So I'll give the introduction. Like nowadays NLP is a growing field, and we see a wide range of applications and feature that we can do with respect to NLP. Similarly, one of them is to interpret the tables. So the use case can be used in terms of any medical or tabular data, or the restaurant menus that we have, or summaries from cricket football game scores, or for the stock price we have various tables. So to generate a meaningful sentence out of that table and giving it to the user is something that needs to be done from a model perspective for a better future, or we can say better understandability for the humans. So for that, currently in this one we are focusing on three transformer based model with which we can do that. One is T5, another one is BART, and the third one is MBART. So we'll give a brief about like what is the background for all of this. So the thing that we are focusing is table to text. So to generate text from a tabular data. So table to text, like in all the webs, and if we see any of the like CricBus is an example of the platform where we can fetch the real-time sports. So all the data comes in a tabular format. If we consider any stock market tool like a screener where it shows the profit and loss statement of a company, it comes into a table. So to get the meaningful sentence out of the table instead of going through the table statistics, so we use table to text conversion. And for that, the models that we can use is like transformers, uh, uh, in transformer T5, BART, and MBART. So I'll just give a brief about what are the transformers. So prior to using transformers, we used to use a various state of art mechanism like recurring neural networks, LSTM, GRUs. But the thing with transformer was it makes the use of attention mechanism. So here the training data and the accuracy is more compared to the previous RNNs, because there they won't be using the attention mechanism. So what exactly is the attention mechanism? What is the architecture? So I'll try to explain. So this is the architecture of a T5 based model. So in normal layman terms, T5 is an encoder decoder model, which is pre-trained on multitask, and it is a mixture of both supervised and unsupervised tasks. So to the left hand side, we can see in the diagram, this is the encoder part, and to the right hand side, it is the decoder part. So the work that T5 can do, it can be used in terms of the translation of languages, like from English to German, to summarize a particular text, or to predict the similarity among two sentences. So for all these purposes, T5 can be used. So in the next slide, we are just explaining like what is the encoder. Like encoder was the left hand side, it has the identical layers, and decoder on the right hand side, it has like it used to give that particular output. So in this example, we can see like what exactly or how exactly T5 works. So if I give a particular sentence to my model like welcome to India, to a T5 model, it will try it, and I give like we need to translate it to German. So it will give us the output in German. Similarly, if I give a full sentence and I tell my model to please summarize this particular sentence, so it will summarize that particular sentence into a short form. So similar to that, like if we have seen, there is a mobile app known as InShots. So what they do, they try to give the data in your mobile screen in a summarized way. So backend, they are also using various transformer models so that they can summarize the text of a news from a various web sources and give only the necessary information to you. So like this is the T5 framework, and it can be used in various tasks like translations, classification tasks, regressing tasks, document summarizing articles or from various websites and all. So with this respect, T5 can be used. The second model that we have considered for our research is BART. Like BART is the bi-directional autoregressive transformer. So it is also a self sequence to sequence model, and in this particular one, with this respect to the diagram, I'll try to explain. Here, like we give the source data and we add noise to like corrupt the particular text. Then the next step, it will go to the denoiser. Denoiser will be our encoder or decoder model, and then we'll generate the regenerated text. So the regenerated text also, it will give the feedback back to the denoiser in terms of like loss optimization via backpropagation. Backpropagation is like to adjust the previous weights from the feedback that we have received. So this model is like also works for various NLG tasks like translation, summarization in terms of text classification, or if you want to make a Q&A bot. So this is what MBAT can do. And here we have means this is the architecture of MBAT, means BAT, how it can do, and it is also like similar to sequence to sequence model, and it also works as an auto encoder. So the difference, like we can say there are pre-existing model. What is the difference? So in terms of BERT, like the transformer model, what it differs is like here we use JLU instead of ReLU activation layer. Like in BERT, we use ReLU, and in this particular BAT, we use GALU in terms of the ReLU function. And in terms of the application, like how and where BAT can be used, so it can be used in sequence generation, token classification, sequence classification, like machine translation, language translation purposes. We can use BAT. The third one that we have considered for our comparison is MBAT. MBAT is also a sequence to sequence denoising autoencoder model. Like here we can pre-train our model. Here also it is similar to the BAT, but it has some additional functionality, and the majorly used for the reconstructing part of the text. So like the what we say how MBAT is better in terms is that it learns some structure of language during pre-training itself, and this structure goes beyond the linguistic borders and allow the language transfer or the knowledge transfer between languages. So if we fine tune a MBAT to the language related problems, then it will be the best one that can be solve the problem of language translation and machine translation. So like what was the inference after our research on these particular three techniques? Like one of the advantage of using T5 over other, like it provides like it does not provide like the other model doesn't provide a label or a span of input as an output to the provided sentence, but it generates the output as a single string format. And BART is very flexible and means it can be like we can use it by using the default tuning parameters in effective cases, means in terms of BART. And MBART is like the multilingual model with the encoder decoder methods primarily used for translation, but it is not limited to that. Like this in terms of the M that stands in MBART is like for the multilingual thing. So it is multilingual in nature, and it expects a sequence in different formats. So this was the inference from this particular three study. And in terms of the conclusion and future work that we are trying to do is like here we just have done this survey on these three transformer models for table to text generation and the approaches how we can do that. As an extension, we are planning to implement T5 based transformer models, and for that we have done some research. There is a data set that is available by name of Toto, that is given by Google. Google has open sourced that particular data set, and in this particular data set we can train the model on the maximum possible epochs that we can do either in our normal CPU or in terms of the GPU. And we can optimize the solution by creating dynamic interface where suppose we can directly provide the like input, or we can directly provide the link of a web page, and automatically the model can give us the output. Like we can give a web page link of a particular stock, suppose considering Tata Motors in that particular model, and from that particular web page link it will try to generate the sentence by reading the tables. So this we have taken it as a future work, and currently we are just figuring out the data set and everything we are doing in terms of pre-processing and all. And in the later stages we will be implementing T5 to generate a full user interface where you can give any URL from the web, and automatically by seeing that it will try to predict sentence going through the tables. So this is the work that we have done as of now. So thank you everyone for your time.